This is Sarah Wilkinson from Humber College and the University of Guelph-Humber. In this second video in the lactic acid and exercise physiology series, I'll be covering the rate of energy expenditure and exercise intensity. Please ensure you've watched the introductory video and that you're familiar with ATP producing pathways. We know that as exercise intensity increases, so does the rate of energy production. That is, how much ATP is produced per minute. And people who can exercise at very high intensities, for example, riding their bike very quickly, running very fast, can produce more ATP per minute. There are many ways in which skeletal muscle can produce ATP, and I'm going to list them from fastest to slowest. Phosphocreatine, which is the substrate for a one-step reaction to produce ATP, will allow very fast ATP production. The next fastest pathway for ATP production is using glycolysis, which either uses glucose or glycogen as substrate. If the product of glycolysis, pyruvate, then moves into the mitochondria and undergoes aerobic carbohydrate metabolism, this is the third fastest way of producing ATP. Finally, the slowest ATP producing pathway is using fatty acid to produce ATP. Now, it's not an all or nothing thing in skeletal muscle. All these pathways are performing at one time. Just one dominates. So, for example, at rest, we rely primarily on aerobic fat metabolism, and as we start to exercise with greater intensity, other pathways may produce a greater percentage of the ATP. So, at low intensity of exercises, we can rely on aerobic ATP production. But as we need to do more work or produce more power, we need to start to use some of our non-aerobic ATP production to supplement the ATP being produced using fat. Therefore, as exercise intensity increases, we rely more and more and more on glycolysis. The reactions in glycolysis speed up so that there is more product. So to add to our very important points from the previous video, during higher intensity exercise, where we need to produce ATP faster, we're going to rely more on carbohydrate because that's the substrate for glycolysis. This means that there's an increased speed of glycolysis. This will become important as we start to talk about lactic acid production in future videos. So let's add this third very important point to our first two, which were NAD is needed for glycolysis to continue, and pyruvate and NADH produced from glycolysis needs to move from the cytosol to the mitochondria. Let's continue on to the third video in this series, the factors that govern lactic acid formation.